Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we'll learn about sequential control. These will be some series videos. So this is part 1. So what is sequential control? Sequential control can be pneumatic system or it can be some kind of other mechanism or machines. They are designed to perform a range of tasks in a certain order or a sequence. So let's look at a question. Here the question states that perform a single sequence operation A plus B plus A minus B minus. So from this question we can already deduce that A and B are two cylinders. Here plus means extending and minus means retracting. So A plus means cylinder A is extending, A minus means cylinder A is retracting, vice versa for B cylinder. So let's draw the circuit. So these are my two cylinders, cylinder A and cylinder B. These both cylinders are double acting. Here I put some identification like in the software, so it will sense the position. Think it like as a lever plunger. So control a double acting cylinder, we need 5 by 2 DCV. So these are my two 5 by 2 DCV. To control this, we need 3 by 2 DCV. Okay, so I have all the components. Now I have to configure this 3 by 2 DCV. To follow along with this video, you need the knowledge of roller plunger, which I have discussed in the earlier video, automatic and semi-automatic in pneumatic. It will appear in this I button here. First, watch that, then come to this video. The question states that perform a single sequence A plus B plus A minus B minus. So this sequence will happen only once and it will be initiated by the operator. So first of all, A plus needs to happen by the operator. So this is for the operator. I will give a push button here for the operator. Okay, so if operator pushes this button, then a signal will go here and this side will actuate. Then flow will go to left side of the cylinder and A1 or A plus will happen. After A plus, I need B plus to happen. So B plus is here. To initiate B plus, I need to configure this DCV and this side. So let's draw it. I will configure is this as roller plunger. Now to connect. And this roller plunger will sense A1. So after A plus happens, this roller plunger will get triggered. This side will get actuate. Signal will go here, then here, and B plus will initiate. Now, after initiating B plus, what do we need? We need A minus, and A minus is here. To initiate this, I need this side to actuate and this side to actuate. I need another roller plunger here, and this roller plunger will sense B1. So after B plus happens, this roller plunger will get actuated, signal will go from here, then here, and A0 will actuate or A minus. After A minus actuates, I need B minus. I need signal in this side, I need to actuate this side, and I need to actuate this 3 by 2 DCV. So this also be configured by a roller plunger. This roller plunger will sense A0. So after A0 happens, this roller plunger will get activated. This side will get actuate, signal will go here. This side will get actuate and flow will go through here and cylinder will get retracted. B0 will initiate. So that's all. That is the whole operation and the operation will get stopped. Another thing I want to mention is that I am drawing roller plunger like this. This can be also drawn like this because this sometimes called the ideal roller, which is completely different from a roller plunger. So it's appropriate to draw like this. Let me quickly change this. Now I want to show you two things, the step diagram and timing diagram, which is important for theory exams, might come in handy to you sometimes. So these are the step diagram and time diagram of this circuit or of this problem. So you can see step diagram consists of a whole square. In the step 1, A plus will initiate, then step 2, B plus will initiate, then step 3, A minus, and step 4, B minus. 1 means extending and 0 means the cylinder is retracting. For the displacement time diagram, only a single point consists of time. From time T1 to T2, A plus is initiating, T2 to T3, B plus is initiating, and so on. Now let me show you the simulation. Here I exactly did what I drawed, but I added something new. Here you can see a throttle valve and a check valve. This is called the meter-in circuit, which controls the inflow into the cylinder. These things I already mentioned in my flow control video. I advise you to watch that first. I added this flow control to reduce the speed of the operation so you can easily understood what is happening. So let's simulate. Here operator will push this button. After pushing this button, look closely what happens. A1, B1, A0, and I did not need any identification here because that was unnecessary. In the actual solution, you do not need to add this meter in circuit. I added this because it will control the velocity of the operation. If you didn't understood any part, then feel free to comment. And if you have any problem in any kind of sequence, please let me know. I will make a separate video for that.